Alrighty, let's take a look at the Math 3 Midterm 1 review. So, my suggestion is for you guys, to try these problems on your own first instead of just watching the video and copying it down. So, try it first and then you can use it to check your answers and see what you did wrong and make mistakes, fix your mistakes and all that. Now the test is going to be very similar to this, same format, same types of questions, basically different numbers. So if you understand how to do this, you should rock the test just fine. So the first ones are just basically matching. We're matching the equations and we are matching the names and the graphs. So linear, remember, means a line. It's a straight line. So where's our straight line? It's right there, H. What does linear look like? Well, it doesn't have any exponents, doesn't have a square root, doesn't have absolute value bars. It just has an x, and that's pretty much it. So it would be D. Okay, now exponential. Remember, exponential, that's the only one that has an exponent of x. So the equation should be pretty easy to figure out. It's the only one with that exponent for x. Okay, now the graph might be a little trickier. Remember, with exponents, they grow quickly. So it actually looks like L. That's what an exponent looks like. Okay, now let's take a look at absolute value. Remember, absolute value, it changes negatives to positives, so it's in the form of a V. Not a soft V like this one, but a hard V like that one. And its graph, or its equation, is the only one with absolute value brackets. Okay, so this is basically just knowing and having it memorized, essentially, is the way you got to do this one. Now quadratic, that's one you dealt with a lot last year. That's the one that has the square. Okay, so its equation is B, and it looks like the U. It's a parabola, so it'd be J. Okay, square root, that one's the opposite of a quadratic, so the opposite of squaring is square rooting. So it'd be C, and its graph kind of looks like a sideways parabola with only half, which would be I. And finally, we've got the cubic. The cubic is the weird one with the jog in it, so it's K. By jog, I mean you're going and like, whoop, you jog it. And it's the cube, so it's E. So make sure you understand all of those ones. That's basically what you've got going on. Okay? So there's going to be some matching. Next up, we have to deal with some inverses, because a lot of what we're doing is dealing with inverses. So find the inverse of each function. So f of x equals 2x minus 5. If f of 1 equals negative 1, what is the inverse? Remember, that sign means inverse of negative 1. And if you remember when talking from our homework, the inverse is the opposite. So if I take the input of our function and we get an output, okay, that input will go back and give us the opposite output. So you should be able to look at this and realize, hey, those are the same number, which means these have to be the same number. So this would be my answer. If you weren't sure, you could take this one and find its inverse and go from there. Remember, we can think about an inverse like this, finding an inverse. Okay, so think of f of x as y instead, same thing. Swap those two out, so x where the y is, y where the x is, and then solve for y. So we'd add 5, we're going the opposite way, so x plus 5 equals 2y, divide by 2, so we get x plus 5 over 2 equals y, which we really said was f of x. So if I'm looking for f of negative 1, because now this is the inverse, I plug in a negative 1 for x, and we solve negative 1 plus 5 is 4. And we get 4 over 2 is 2. Okay, what just happened here? Did we do everything right? 2x minus 5. Added 5 to both sides. Divided by 2. Huh. This is weird. Because we should have ended up, because if we're talking about the inverse, we should have ended up... Oh, here's our issue. Duh. Apparently when I made this, I changed a function, and that would actually give us a different number, wouldn't it? Okay, that's where we ran into an issue. So we should have actually had f of 1 equaling negative 3. Had we plugged in a negative 3 here, we would have got back to a negative 1. Right? So 2 times 1 would give us negative 3. Plug in a negative 3. Negative 3 plus 5. Oh, that's a positive 2, not a negative 2. That's where we made our issue. So I just probably confused you guys immensely, didn't I? Alright. That's nice. So, the basic idea still stays the same. Okay, we should have had it written, my problem should have been written differently. That's where the issue ran into. Should have been f of 1 equals negative 3. What is f of negative 1 at negative 3? Then when we do it this way, we get the right answer. So I hope that didn't confuse you too much. We'll talk about this one in class, don't worry. Okay, let's take a look at 8. So 8's the same idea. We've got our function. We want to find the inverse when it's 8. Okay, so there's two ways we can do this. You can hurry and find the inverse by making g of x y, and then swapping out x and y to find, because that's what we do with inverses. We're swapping the domain and the range, the x and the y, and then solve for that. So first thing, we need to get rid of that negative, so divide by a negative 1, which would give us a negative x equals y plus 2 cubed. How do we get rid of a cube? We take a cube root. So we'd have cube root, the cube root of negative x equals y plus 2, and subtract 2. So we get the cube root of negative x minus 2 equals y. So our inverse function would be, let's write it the correct way, right? G negative 1 of x would equal the cube root of negative, oops, oh my goodness, it's not my day today, negative x minus 2. Okay, so if we find that, then we just take the 8 in there, we get the cube root of negative 8 minus 2. Well, you can use your calculator. The cube root of negative 8 would be negative 2 minus 2 would give us negative 4. So, there we go. That would be our answer. Okay? That's one way we can do it. The other way we can do it is to just go, okay, the inverse is its input would be the output of this. So I know that this g of x, g of some number, is going to equal 8. So I could put that g of x, I could make it 8, and then solve for x. You're really doing the same thing, because watch what you'll do. Before we did that as the x, well, I'd have to divide by a negative 1, which would give me negative 8, equals x plus 2 cubed. I'd have to take the cube root. Cube root of negative 8 would be negative 2, equals x plus 2. Then subtract 2, and we'd end up with negative 4. Okay? Either way you do it, you end up with the same thing. So, you're doing the same process, just one you're doing it without the inverse, the other one you are. So I know that g of negative 4 equals 8. Alright, so 9 and 10 want us to decide if these are inverses of each other. Okay, so the best way to test that is to do those compositions. Okay, find out what g of f of x equals and f of g of x equals. Okay, and then by showing that work, you can say because they equal this certain thing. Remember, what we want them to equal is x. So let's start out with g of f of x. So I take negative 7, and I'm going to put the function f of x inside of it. Negative x plus 4 over 7 plus 4. Okay, so a negative 7 times a negative x plus 4 over 7. Okay, those 7's would cancel out. We'd have a negative times a negative x, or I guess we could just say negative 1 times negative x plus 4 plus 4. Negative 1 times through there, that would give us a positive x minus 4 plus 4. Minus 4 plus 4 would cancel out, and we'd be left with x. Okay, which is what we want to end up with. That's what we want to end up with. Okay, now we got to test it the other way around. And you've got to test it both ways, or else you're never sure. Just kind of like how I made that mistake on that last problem. If you're not doing it, the whole part and checking, you'll make a mistake. So this time, we'll take f of g of x. So we start out with our function f. So I'm going to go negative. Inside the x, we put the whole thing, negative 7x plus 4 over 7. Distribute that negative through, gives a positive 7x minus 4 plus 4 over 7. Minus 4 plus 4 gives us 0. 7x over 7 gives us x. So it's true. So showing that work, I would then say the y would be, their compositions both equal x. That would be my reasoning. Okay, now let's try it with number 10. Same concept. Same exact concept. So I take h of f of x equals, so it would be parentheses, let's see, parentheses, instead of x, I put that whole thing in. I substitute the whole thing in, x plus 2 for x minus 2 squared. Now this plus 2 is inside, not outside of it. So that comes into play. Okay, so we've got a square. Now, when we square something like this one gets tricky. X plus 2 minus 2 times x squared of x plus 2 minus 2. So, multiply those together, we end up with just x plus 2. Multiply that, minus 2 square roots of x plus 2. We're just foiling here, multiply that, minus 2 square roots of x plus 2. And multiply those, negative 2 and negative 2, positive 4. Then simplify. 4 and 2, I know I said it backwards, give us 6. X stays the same, so we got x plus 6 minus negative 2 and negative 2 make it negative 4 square roots of x plus 2. Okay, can we simplify that further? No. Does this come up to x? So my answer is no. They are not inverses of each other. Okay, because we have all this extra crap with us. Now I could have done it the other way around and went the square root of x minus 2 squared plus 2. And I should have seen pretty quick, I'm not getting rid of this because of this plus 2, so it's not going to work out for me. Okay? So you've got to check those. So one yes, because they came to x, one no, because they didn't. Okay, now let's look at some inverses of tables. So we've got to find tables that are inverses. So let's start with A. Remember, on tables, the inverses, we're just swapping. Okay, so 60 still has to be with 0. So look for a 60 with a 0. So we've got this possibility or this possibility. Okay, so let's see. If we look at H, hopefully it's pretty apparent that some of these switched, but some of them didn't. Okay, so that one's not it. Let's check this one. 0 to 60. Okay, 1 to 56. Matching up. They just swapped positions, so A and F work. Okay. Now let's try B. We've got negative 25 and negative 2. So let's see. This one could be a possibility. This one could be a possibility. Or this one could be a possibility. So negative 25 to negative 2. Negative 25 to positive 2. Okay. That already rules that one out. Okay. With, one of these is ruled out, I should say. Okay, what about this one? Do we have a negative 25 with a positive 2? Yeah, it's on the bottom, but with a table it doesn't matter what order you put it in. Is it negative 20 with 1? Yes. Is this negative 20 with positive 1? No. This is actually the odd one out. These two. D and I. You can check all the rest. Okay. Now the last one are going to be these three, right? We're seeing 9s and 1s. So we've got a 9 and a positive 1, or 9s and negative 1s. Okay. Remember, inverses don't change positives to negatives. They just change them back and forth, which C and G are going to be our inverses. Just checking those inverses. Okay, now we're going to have to find the inverse and then graph it. So remember, when we're dealing with graphs, the graph at y equals x, an inverse is just translated, or not translated, reflected over this line. Okay, so this piece would jump down here, this piece would jump up there. Okay, if we found some points here, we could swap the points out. So for graphing, I could take this point and this point, this point, this, here's a bunch of points, and I could list those points, or at least, 3 of them. This would be negative 7, 0, negative 4, 1, negative 1, 2, 2, 3, 5, 4, and 8, 5. And then I could just swap them. So instead of negative 7, 0, I would have 0, negative 7. Okay, and I'll make that one a different color. I would have 0, negative 7. Instead of 4, 1, 1, negative 4. Negative 2, negative 1, 2 would become 2, negative 1. And so on. So I just swap them. If I did that, 0, negative 7 would put me down here. 1, negative 4. See how it's going transforming it over that y equals x. 2, negative 1. Then instead of 2, 3, we'd go 3, 2. So 3, 2. Okay. And I'm doing it on the same. Instead of 5, 4, it would be 4, 5. So right there. And instead of 8, 5, it would be 5, 8. Okay, so then I draw my line. Notice how the black looks like it's kind of twisted over that, reflected over it. So I could do that. I would, of course, want to graph it over here. Instead, I graphed it on that other one just to show you how they're connected. And there we go. There's our inverse graph. Now how do we find the function? Well, remember, we take this, alright, y equals x plus 7 over 3. Swap out the x and the y, so it would be x equals y plus 7 over 3, and then get y by itself. So I'd start out by timesing both sides by 3 to get rid of those 3's. So we'd have 3x equals y plus 7 minus 7 3x and 7 aren't the same, so we can't combine them. So we get this. So I just rewrite it as our inverse function equals 3x minus 7. Okay? And that's all we got to do. That's how we get the graph and the inverse. So looking at 14, now we're dealing with a square, but it's the same process. This time first let's find the equation. So swap the x into y, and then we're going to solve for y. So first I've got to deal with this 2. X minus 2 is not negative 2x. It's x minus 2. Can't combine them. Now that we've just got the squared term, to get rid of the square, we square root it. So we square root all of that x minus 2 equals, those cancel out, and we end up with y minus 1. Add 1 to both sides. We get the square root of x minus 2 plus 1 equals y, or the inverse of our function equals the square root of x minus 2 plus 1. So, how do we graph that? Well, we're essentially, we're rotating over that y equals x. So if we find a couple of points, we could even make a table if we wanted to, if that would be easier. So we've got a point here, 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 and here. So we've got negative 1 for x with 6. We've got 0 for x with 3. We've got 1 for x with 2, then 2, 3, and 3, 3. Or 6, 6, sorry. 3 up 6. Okay? So if that's our functions, then for our inverse, we just flip it, right? So for this one, let's give us some more room. Okay, keep that x, keep that y, but we swap them. So now x is 6 and y is negative 1. 3 and 0. 2 and 1. 3 and 2. And 6 and 3. Ran out of space, didn't I? So let's graph them. So x value of positive 6, y value negative 1. 3, 0, 2, 1, then we had 3, 2, and then 6, 3. Okay, so it looks like the sideways version of it. Okay, and that's what the inverse would look like. Now, if you type this in a calculator, it's probably just going to give you this half of it. That has to do with the function idea, because if we did this, it doesn't pass the vertical line test. So when you're dealing with inverses of squares and the square roots, you only graph half of it, typically the positive half. But for me, on this test, if you do this, that's fine by me. Okay? Well, there you go. If you have any more questions, please come talk to me. But hopefully that helped out.